Hello gentlemen, welcome back. We're going to continue on in this video looking at partial fraction decomposition. We're going to look at some more involved problems with repeated linear factors and quadratic factors. Okay, hopefully you guys got a good understanding from the last video of the real basics. We had linear non-repeating factors. Hopefully you understood that decomposition. And what we're going to do now is look at a couple more, a little bit more in depth, and how to handle different situations. Okay, again, take some practice, but follow along on this video and so you'll understand the different situations. Okay, so let's get started. Here we're going to end up with one with a repeated linear factor. Okay, so we want to write the partial decomposition of the following expression. Well, first thing we do is look at the power in the numerator and compare it to the power in the denominator. And the denominator is greater, so no need to divide here. Okay, long division is not necessary. So next step is I want to factor. I want to factor the denominator here. And so what I see is that this is a perfect square, and I get x minus 1 squared in the denominator. And so at this point, I want to decompose. Okay, but I have to note that I have a repeated linear factor. And so I have to use each factor, I have to put a constant in the numerator for each factor. Okay, for each power of that linear factor. Okay, in other words, I'm going to put a over x minus 1. Okay, there's the power of 1 plus b over x minus 1 squared. Okay, and so whenever I have a repeated linear factor, I need to use it twice. Once with the power of 1, once with the power of 2, that one factor. Okay, once I get to this step, it's the exact same as what I've done before. All right, what I'm going to do is I'm going to multiply by the least common denominator, least common multiple here, which is x minus 1 squared. On the left-hand side, I'm just going to get 2x minus 3. I'm going to get a times x minus 1 plus b. And what you should see here to find b, it's real easy. To find b, just plug in x is equal to 1. And then I can plug in any value to get the value of a once I get the value of b. If I plug in the value of 1 to get b, this term goes away, and I should get that b is equal to negative 1. Okay. And then once I know that b is negative 1, I can plug in, like I say, 2 here to get value of a. If I plug 2 in here, it gives me a coefficient of 1, so I get a minus 1 is equal to 1, so a is equal to 2. Again, let me just show you that last step a little bit. Okay, once we found that b was equal to negative 1, I plugged in 2, and that would give me 4 minus 3 is equal to a minus 1. 1 is equal to a minus 1, and that's where a was equal to 2. Okay? And I would rewrite my partial decomposition like this. All right, hopefully that makes sense. So again, repeated linear factor, I have to have a constant in the numerator over the linear factor to the power of 1, and then I add plus b over the linear factor squared. Okay? Here's the situation again. Let's look at it. First step is to check the powers. Again, I'm greater in the denominator. No need to do long division. Here I'm going to end up with a quadratic factor. All right. So the first step I want to do is try to factor. Obviously, I'd factor the numerator too if I can, but I cannot. I can pull out an x term. So I have x over x squared plus x plus 1 in the denominator. This time I have to decompose, and here I have a linear factor and a quadratic factor. Okay. When I have a linear factor, I just put a constant in the numerator. When I have a quadratic factor, I have to put a linear factor, which is a bx plus c. A linear factor has an x term and a constant term. Okay, so remember, whenever I have a quadratic factor, I have to have a linear numerator. Okay, bx plus c. I'm going to go about this process. This is a little bit more in depth, but I'm going to go about the process the same way. Multiply by least common denominator. And what's going to happen is this term and this term is going to go away. And on the left-hand side, I'm going to x squared minus x minus 1. But then I get a little bit more complicated as I go through this way. Okay. So after I do that, this is where I end up. Now, for this particular problem, again, I'm looking for x values that I can simply plug in and see if I can get a, b, or c. And what I should see is if I plug in x is equal to 0, I'm going to get my a value pretty easily. Okay, because this term will go away, this term will go away, I'll get a is equal to -1. So I can get that part of it. The other thing I want to try to do is to group. I want to try to group by terms. So I want to get all the x squared terms together. I want to get all the x terms together and all the constant terms together. That's what I've done right here. Okay, and then once I get to this step, I know that the coefficient of the x squared terms has to be the same. So the coefficient of x squared here is 1, and coefficient is a plus b, so a plus b has to equal 1. A plus c has to equal -1, and like I said earlier, a has to equal -1. Okay, so the coefficients of the similar terms have to be the same. Okay, so I get a is equal to -1, and the next step is the coefficients for the x squared and the x terms must be equal, like we said. And so that means that a plus b is equal to 1, but if a is equal to -1, b is going to be equal to 2. And I know that a plus c is equal to -1, and then c would be equal to 0. Okay? And then the final step is obviously to write this in my partial fraction decomposition like that. Okay? That one was a little bit more involved for sure. This one's actually even a little bit more involved. We have a couple coming up here. First off, note that the power in the numerator is greater than the power in the denominator, so the first step has to be divide. Okay? And so you guys need to be able to do the long division. Let's do it out. You guys should pause it right now and do it and make sure you get the same thing that I get. Plus 1 all divided by x squared plus 3x minus 4. I'll get an x cubed plus 3x squared minus 4x. Need to subtract -x squared plus 3x plus 1 minus 1 minus x squared minus 3x plus 4. I'm going to get 6x plus 5. And so what I will get here is x minus 1, 6x minus 3. Oh, I'm sorry, that is minus 3. Got to change the sign. Okay, so 6x minus 3. And now what I want to do, make sure you guys can do this step. Now what I want to do is I want to do the partial fraction decomposition right here. Okay, so I have to factor the denominator here. And if I do that, I'm going to get x plus 4 over x minus 1. Again, these are just both linear terms. All right, I know how to handle linear terms. Do it just like this. Multiply by least common denominator. X plus 4, x minus 4. This term goes away. So I get 6x minus 3 is equal to a times x minus 1 and b times x plus 4. Because these are linear factors, I can choose x equals 1 to solve for b, and x equals -4 to solve for a. Okay, and if you do that, you guys should be able to do that. You get a is equal to 27/5 and b is equal to 3/5. Okay, not the greatest numbers, but you guys should be able to do that, show that. Okay, final step is, again, we've got to bring that x minus 1 term back. Okay, so it's x minus 1 plus 27 over 5, x plus 4, plus 3/5, 3 over 5 times x minus 1. Okay, so there's the partial fraction decomposition of that term right there. Got one more. This is definitely the most complicated one that we have done to date. Let's look at this. We want to factor the bottom. Doesn't look like it's factorable, but we're going to do factor by grouping here. In this term, I'm going to take out an x squared. In this term, I'm going to take out a -3, like that. Now, both of these terms have an x plus 2 in it. So I'm going to have two factors like that. Note here that I have a linear factor and a quadratic factor. All right, so now when we go to do the decomposition, on the quadratic factor, I have to have a linear factor in the numerator. So that's my ax plus b. My linear factor, I just have a constant. Okay, So here I am. This is the decomposition setup. Now what I want to do is multiply by x squared minus 3 times x plus 2 like we've been doing. The left-hand side becomes x plus 6. I have ax plus b times x plus 2 and c times x squared minus 3. I want to simplify and combine terms. Okay, and I can actually solve for c quite easily here because I can get rid of this term here by plugging in negative 2. If I do that, I'll get c is equal to 4. That term goes. I get 4. I get c right here. C is equal to 4. You guys should see that. Plug in that negative 2. Okay. Coefficients of the x squared and x terms must be equal. We've already done that before. So again, I want to group things out here. All right. And if I group them out, I'll get it like this: a plus 4 x squared plus 2a plus b times x plus 2b minus 12. You guys need to go through the steps. Make sure you understand how I went from this step to that one with c is equal to 4 because we already found c because that was easy, and then from here to here. It's all algebra here. Okay. Now I should note there's no x squared term here, so a plus 4 must be equal to 0. So a is equal to negative 4. And I should note that 2a plus b has to equal 1, the coefficient of the x term. And I know that a is equal to negative 4, so b is going to be equal to 9. Okay. Now I can plug back in. Here's my decomposition right there. I know all those values, and so I can finally write that this is equal to negative 4x plus 9 over x squared minus 3 plus 4 over x plus 2. Again, you guys can go back, get a common denominator, and show that this side here is actually the same as that up there. Okay? Definitely some more complicated problems than we've done in the past. But remember, after you've done, you've done your long division, if necessary, you have your factors and your denominator, all linear factors. Okay, if I have a linear factor in the bottom, I put a constant on the top on the numerator. If I have a repeated linear factor, for example, x squared, I have to do one term as a over x, and then I have to do one as b over x squared, that value squared, that second factor. Okay. When I have a quadratic factor, I have to have a linear factor in the top. All right, so hopefully that makes sense to you. All right, here's some practice problems that'll practice with repeated linears and with quadratic factors. Okay. Again, attend Google Hangouts if you're having some trouble, or shoot me off an email. All right, fellas, have a good day.